Hi, and welcome back to this AI-900 Azure AI Fundamentals course. In the previous lessons, you learned about AI workloads, responsible AI, and the main machine learning types such as regression, classification, clustering, and deep learning. In this lesson, we will connect those ideas with some essential machine learning concepts and with Azure Machine Learning, the main platform on Azure for building, deploying, and managing ML solutions. By the end, you should be able to explain what features and labels are. Understand why we split data into training, validation, and test sets. Recognize overfitting and underfitting. And identify when Azure Machine Learning, AutoML, the designer, and model deployment are the right tools for a scenario in the AI-900 exam. If this content helps you, remember to like the video and subscribe to the channel so you don't miss the next lessons. Let's start with features and labels. In supervised machine learning, the label is what you want to predict, and the features are the inputs the model uses to make that prediction. Imagine a model that estimates house prices. The price itself is the label. The size of the house, the number of rooms, the neighborhood, and the age of the building are features. For a churn prediction model, the label answers the question, did this customer churn, yes or no? Features might include how long they have been a customer, how often they use the service, their payment history, and previous support tickets. On the AI-900 exam, if you see a table or dataset description, look for the column described as what we want to predict. That is the label. The other columns used as inputs are the features. Now let's talk about how the data is split into training, validation, and test sets. When you build a model, you don't train and evaluate on exactly the same data, because that can give you an overly optimistic view of performance. Instead, you split the data into different parts with different purposes. The training set is used to fit the model and learn patterns. The validation set is used to compare models and tune options such as hyperparameters. The test set is used at the end to estimate how well the final model will perform on new, unseen data. The key idea here is generalization. A good model should not only perform well on the examples it has already seen, but also on new data that comes from the same problem domain. On the exam, good practice looks like train on one dataset and evaluate on a separate one. Bad practice looks like train and evaluate on exactly the same dataset with no separation. You don't need to memorize precise percentages, but you should understand why we use a training set, a validation set, and a test set. Next, let's explore overfitting and underfitting. Overfitting happens when a model learns the training data too well. It picks up not only the real patterns, but also noise and random fluctuations. As a result, it performs extremely well on the training set, but much worse on new data. The typical symptom of overfitting is high accuracy or low error on the training data, and significantly worse metrics on validation or test data. In contrast, underfitting happens when the model is too simple or not trained enough. It fails to capture the underlying patterns in the data. In this case, performance is poor on both the training set and the test set. For AI-900, you are not expected to tune models in detail, but you should be able to recognize these two situations in simple terms. Overfitting is memorizing, training examples and failing to generalize. Underfitting is not learning enough from the data and missing important relationships. Good machine learning practice aims to find a balance, a model that is complex enough to learn useful patterns, but not so complex that it memorizes noise. Now let's connect these ideas to Azure Machine Learning, often called Azure ML. Azure Machine Learning is a cloud platform that supports the entire machine learning lifecycle. You can use it to prepare and manage data, train and evaluate models, automate model selection, deploy trained models as services, and monitor how those models behave in production. In the AI-900 exam, you need a high-level understanding of what Azure ML is for, rather than step-by-step configuration details. One important capability of Azure ML is automated machine learning, or AutoML. AutoML is helpful when you have a well-defined ML problem in data, but you don't know which algorithm or configuration is best. It can automatically try multiple algorithms, explore different hyperparameters, Evaluate each candidate model using appropriate metrics. And present the best performing options for your scenario. On the exam, when a scenario says that a team has limited machine learning experience, wants to quickly find a good model, or wants to automatically explore many algorithms and hyperparameters, the correct answer is often automated machine learning. Another key component in Azure ML is the designer, which provides a visual, drag-and-drop environment for building machine learning pipelines. With the designer, you can connect data sources, add transformation steps, plug in training and evaluation modules, and create end-to-end ML workflows without writing much code. This is especially useful for teams that prefer a low-code or no-code approach, or that want to build reusable pipelines that can be scheduled and maintained over time. On AI-900 questions, keywords like visual interface, drag-and-drop pipeline, or build an ML workflow without writing code usually point to the Azure ML designer. Once a model is trained, Azure ML also helps with model registry, deployment, and monitoring. The model registry acts as a catalog of models. You can store different versions, associate them with metadata, and keep track of which version is currently used in production. You can deploy a registered model as an endpoint so that applications can send requests over HTTP and receive predictions. This allows other systems to consume the model via a REST API. After deployment, you can monitor the model to track metrics such as latency, error rates, and sometimes changes in the data distribution. Monitoring helps you detect when a model needs to be retrained or replaced. Exam scenarios that mention expose the model to other applications via a web service, manage versions of models, or monitor model behavior in production are referring to these deployment and management capabilities in Azure Machine Learning. Let's recap the main points from this lesson. You saw that features are the inputs to a model, and labels are the values the model is trained to predict. Data is often split into training, validation, and test sets to evaluate how well a model generalizes to new data. Overfitting means high performance on training data but poor performance on new data, because the model memorized noise. Underfitting means the model is too simple and performs poorly everywhere. You also saw that Azure Machine Learning provides a workspace to manage ML resources and workflows. Automated machine learning helps non-experts quickly explore algorithms and configurations and select a good model. The designer offers a drag-and-drop way to build ML pipelines. The platform includes model registry, deployment, and monitoring so models can be served and maintained in real applications. For AI-900, your goal is to recognize these concepts and tools in short business scenarios and pick the option that best matches the described requirement. If this lesson was helpful, please like the video, subscribe to the channel, and continue to the next lessons, where we explore Azure AI services for vision, language, speech, and generative AI in more detail. Thank you for watching.